So here's the question we got to answer today. By the time you walk out the door, hopefully we'll all be able to answer this question. That's when will the sine ratio be equal to the cosine ratio? Okay, and hopefully we'll be able to fill in the blanks here when sine and cosine are equal to each other. All right, so let's start here so we can start that out because I'm just not going to give it to you. Can you guys help me find the sine of A right now? Sine of angle A. Just find the ratio, this over this. Okay, so tomorrow you have SOHCAHTOA written down. Somebody remind me, how do you find the sine ratio? How do you find the sine ratio? 5, how do I find it? I take what sides? Okay, I take the opposite side and I put it over the hypotenuse, right? So can somebody give me the opposite side and the hypotenuse for sine of A? A, angle A, opposite over hypotenuse. Just use the variables that are there for me. 11, yep, sure. 9, what's opposite A? Y over hypotenuse? Z. All right, so it's Y over Z. Now I'm going to challenge you. You can do it by yourself or talk to people around you. Can you find me another trig function, meaning cosine or tangent, that's also equal to Y over Z? Can you find me another one that's also equal to Y over Z? Let's go. Try it out because there is an answer. It's not impossible. The answer is not no solution. Find me another one that also equals Y over Z, please. Find me something else that equals Y over Z. Did you find one? Nice. There should be, if there's one in there. Anybody find one here? Spence? Yep, good. And you did what? So you did what? Cosine. All right, great job. Great job. Spence said, hey, so if you want Y over Z, you could also do cosine of what angle, Spence? C, correct. Everyone see that? Cosine of C is also equal to Y over Z. Good work. Good work. So what we just found was the following, that the sine of A was equal to the cosine of C. Everyone agrees? What do you know about angles A and C? Let's take this deeper now. What do you know about angles A and C? In my diagram up there, what do you know about those two angles? Angle A and angle C. Give me something you know about them. Anything.
They're less than 90 degrees.
They're acute. Keep going. They are acute. I don't know that, maybe, but not necessarily. They are acute.
They add up to 90.
Hey! Here we go, boss. They add up. That was awful. That was awful. Never again will you get that. Never again. You can even screw that up. God. Finally, and like that's a rare moment. You get a little something from me, and you just totally screw that up. Say it one more time for everybody. They add to 90, right? Can I get a big boy, big girl word for that? They are complementary. All right, let me try to put this all together now. Conclusion. If angle A and angle B are complementary, all right, if angle A, and I know we just did A and C. I'm not talking about the diagram anymore. I'm just talking about two angles. You could call them X and Y if you wanted to, all right? I'm just talking about two angles right now. A and B. I'm not talking about the diagram anymore. Just two angles are complementary. Here's what we know. The sine of one of them is equal to the cosine of the other angle. But they have to be complementary. So if you know two angles are complementary, the sine of one of them is equal to the cosine of the other. But they have to be complementary. All right, let's use some numbers here, and hopefully this is going to start making sense. I want you to write something that's also equal to the cosine of 20. All right, so everyone put cosine of 20 in your calculator. I'll do it too. So cosine 20, they give me this big decimal, right? I want to type something else in my calculator that also equals that decimal. Okay, so when I type it in, sine, cosine, tangent of this angle, it will also equal this up here. Here's how we find it. Cosine of 20 will be equal to the sine. What did we just write down in your conclusions? If cosine and sine are set equal to each other, their angles have to be complementary. So the cosine of 20 will be the exact same as the sine of what's complementary to 20? 4? 70. Try it out, everyone. Sine 70. Boom, we got a winner. Are you starting to see it now? All right. Sine and cosine will always be equal to each other, only if their angles add to 90. All right, let's try a couple more here. One doesn't make you great. Sine of 37. Give me something that's equal to sine of 37. So something else that's going to equal that decimal for me. The sine of 37 and 13. Cosine of its complementary angle, 53 degrees. Okay, starting to see this now? When sine and cosine are equal, if their angles add to 90. All right, up. Here we go. Now, here's where I need you to be. All right, I'm not really too concerned. You can do 1 and 2. 3's where it's at. X and x plus 2 are measures of two acute angles. And notice what we said. The sine of x equals the cosine of x plus 20. Whoa, 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 whoa. If you're going to set sine and cosine equal to each other, what am I going to know about their angles, x and x plus 20? They're not equal. Don't set them equal. That's not what we've been talking about. If sine and cosine are equal, what should I always know about their angles? They add to 90. So I'm going to set up an equation that's equal to 90 here. That says those two angles, x and x plus 20, equal 90. Because, hey, again, the only time sine and cosine are equal, look, is when their angles add to 90. So that's why I'm adding those angles and setting them equal to 90, because that's the only time you put sine and cosine equal to each other. So find x. X equals 35. Are we okay here? Before I get in some different type problems. Sine and cosine equal to when the angles add to 90. All right. All right, what else we got here? Okay, so triangle ABC. C is the right angle, so A and B are your acute angles. Cosine of A is radical 21 over 5. What's the sine of B then? Don't overthink this. What do you know about A and B? If C is your right angle, what do I know about angles A and B up here? C is my right angle. 5, what do angles A and B have to add up to? 90, right? So the cosine of 1 is equal to the sine of the other. So if cosine of A equals radical 21 over 5, what else is equal to radical 21 over 5? Shouldn't need any calculator help here. No calculator help. None needed. Oh, hey. The cosine of one of the angles is equal to the sine of the other. Yes, that's what we just talked about, right? If the angles add to 90, cosine of one equals sine of the other. So if cosine of A is radical 21 over 5, guys, what's sine of B equal to? Radical 21 over 5. They equal the same exact thing. Again, how do I know they're equal? What do I know about A and B? They add to what? 90 degrees. All right. When two angles add to 90, cosine of one equals sine of the other. All right, let's keep going. Let's see if we pick this up. Right triangle ABC. C is your right angle. Again, so now that tells me A and B add to 90. Cosine of B is 5 over 13. What's something else that equals 5 over 13 then? If cosine of B is 5/13, so I say to myself, all right, cosine of B will also be the same as 1. Anna, what else equals the cosine of B?
The sine of A.
Sine of the other angle, which is A. So if 1 equals 5/13, so does the sine of A. And then here's where I'm really going to see if we picking this up. I know you guys just want to set them equal and solve for x, but no. Look. They're saying sine and cosine are equal. So in your mind, you're saying, wait. There's only one instance when that is true. Sine and cosine are only equal when I know what about my angles? What do you need to know about the angles if they're going to be equal? 3, sine and cosine are equal if the angles. Okay, so that's what I want. What am I going to add to 90 here? 40 minus x plus 3x has to equal 90 for sine and cosine to be equal. Don't set them equal. They add to 90. They add to 90. So if you know two angles add to 90, their sine and cosine is equal. Sine of one equals cosine of the other. And then 7. Okay, I got right triangle ABC. C's the right angle. Again, A and B add to 90 then. If the sine value of A goes up, keeps increasing, what happens to the cosine of B value? So I'm talking about sine of A. And what happens to the cosine of B? Well, before I talk about what sine A does, what do you know about these two in this problem? What do you know about the sine of A and the cosine of B in this one? They're equal, right? So let's think about it. If this one increases, and they're always equal to each other, what do you know has to happen to cosine of B? But they're gonna, right? If this goes from 5 to 6, this was 5, it's got to be equal to 6, right? Because they're always equal to each other. So as one increases, so does the other. So it increases because, easy explanation, sine of A equals cosine B. Again, last thing, two angles add to 90, sine of one equals cosine of the other. All right, go ahead. This is a mixed bag here today. You'll see some stuff we just went over, which is on the quiz. It's a mixed bag. You get done, you open up that Chromebook and you check those answers, please. Let's get rolling. Yep. Don't set them equal. They're only equal if they add to 90, remember. Sine of one angle is the same as the cosine of another.
No, you don't set them equal to each other. It literally says that people write